Professor Shahid, you can hear me? Professor Shahid, you can hear me? Students, you can hear me?
Yes, sir.
Okay. My sincere apologies. I never know that the link will expire so quickly. So, okay. So as I discussed with you students that it's very important that we should address these issues separately. Okay. And that is why you can see that in order for you to understand it very clearly, I have used a concept of a single microgrid here, where you can see that we have the diesel engine generator, we have the wind turbine, as I discussed with you. It can be the horizontal axis, it can be the vertical axis wind turbine also. We have the battery energy storage system. At the same time, there will be, or they can be the solar PV array also. And as I discussed with you, that there may be possibility that different microgrids will have a different sources. But it's very important that we should forecast the load. We should know whether it's a residential load, commercial load, or it's an industrial load. At the same time, we should have the enough capacity of the energy storage devices so that we can make the microgrid as a self-sustainable. But now, if you remember, we were discussing that there are three issues that we want that quality power should be delivered to the customers of the microgrid. And at the same time, it's very important also that now in order to deliver the quality power, we should follow the rules that frequency should be within certain range, voltage and power quality. So here I have tried to show you the concept that there may be possibility that generation and load will be up and down. We have to maintain the equilibrium in the system, and that is why we need the controller, guys. Okay, you can see that if you see the left hand side of the slide, I have written PIT, the proportional integral derivative, one of the very common controllers used in the, I can say, a lot of areas of the power as well as the control. And if you go to industries also, these guys are very, very comfortable with the PID controller. So that is why it's very important that now we have to maintain the equilibrium between the various sources as well as the load which is connected to the microgrid. That is a different issue. That load need to be forecasted, but still there may be possibility that the minimum cut-in and cut-out speed of the wind is not available. The solar radiation is not available. So at that time, it's very important that we have to cope up with the energy requirements of the microgrid. And that is why you can see that I have combine all the sources in such a way so that there will be an input and there will be output, which is the delta F1, which will be change in frequency. The frequency will only change, as you know very well, regarding the concept N is 120F by P, that it will depend upon the speed of the generator, depending upon how many poles you have in your machine. Okay, so I'm going to next slide. This is the concept of your interconnected microgrid. As I have told you that there may be n number of the microgrids that can be connected. That is known as the concept of multi-microgrid, and these days we are doing a lot of research on the concept of multi-microgrid because we want that microgrid should be self-sustainable. Okay, the power can be exchanged between the various microgrid with the help of the control system, and at the same time, as I have discussed with you earlier also, that there can be 4 or 5 microgrids which are located in the various complexes, and they can be connected in such a way so that they are totally isolated from the utility grid or the power grid. And then we have the controllers to manage the operation of each and every microgrid. So I'm not going into the microgrid modeling because I will discuss with you all these things. Now, cascade structure. Recently, we have seen, as I have discussed with you, that we need the controllers, okay? But now in the design of controller, a lot of research has been done over the last number of the years. And recently, we have come up with the cascade structure. Cascade means that we will have, for example, if you can see that I have one kind of the controller here, and the output of this controller is an input to the another controller. So guys, maybe at your level you have not come across these things, but it's very important that when you design the controller to manage the operation of the microgrid, a lot of research has been done and a lot of things have been seen that there are a number of problems with one kind of the controller, then what to do and how to come up with some kind of the advanced controllers. So here the cascade means that we have, for example, the PI is already available here, and then we have the another PI. So what is the meaning of cascade? Means that first we will optimize. What do you mean by optimize? Means we will find the gains of these controller to achieve a certain output with the help of some kind of artificial intelligence technique. Okay, so it means the value, I can say at your level, the values of KP and KI, the gains of controller will be the optimized value. When these optimized value will work as an input to the another controller, then definitely your output will be much betterly regulated as compared to if you use only one kind of the, or I can say you will not use the cascade structure. Okay, so that is why we have used here the cascade structure, and you can see that we can optimize. We will discuss now what do you mean by optimize, that these values for a certain action. Now, in this research, we have used a GIA optimization, but as I promise you that I will keep this presentation as simple as possible. Okay, so optimization, before we go into the optimization, it's very important, and maybe you have come across your Bachelor of Engineering, that we need to find the gains of our controller to achieve a certain desired output. Okay, earlier, a lot of people were using the conventional techniques. Okay, there are a lot of control techniques also, which are available in the control system. But these days, artificial intelligence techniques are used, which use a certain MATLAB code, or I can say the programming to achieve a certain output. Okay, so it means that we have to achieve, for example, we want that for any kind of the disturbance in the system, okay, our optimization should give us the result in such a way that the values of our controller should act so fast and in one of the optimal ways to achieve our required action. And that is why these days, if you go and see that most of the people, or if you go to any AI-based companies, they use the optimization algorithm. Optimization means that you will use, you know that this is what actually I need to optimize. I want that my frequency, maybe the voltage, or if you want to achieve the power quality issue, should be as minimum as possible. Then what you do is that you define the target. You define the target, but there should be certain limitation. And then optimization algorithm will give you the result on the basis of the targets set by you. So this is one kind of the optimization where we have used ITAE, integral time of absolute error. The main reason is that we have to minimize the error. Okay, so integral time absolute error, error is our frequency, and we want that change in the frequency should be minimized with the help of GIA optimization algorithm. Okay, looking at the time, I'm not going into the further details. So here, what we have seen that for our standalone microgrid, we have plotted the responses of frequency, the power output from the wind turbine generator, power output from the diesel generator, and we have compared it with the help of considering two error definition. One is integral time absolute error, one is integral of absolute error. And you can see that our cascade PI PAD with the help of GIA is giving us the minimum error value. So if error is minimum, then we can conclude that yes, these gains of the controller will be sufficient enough to match the generation with the load. Okay, in terms of with the help of this numerical data. Still, there are a number of the things that can be explored, but for you now to understand the concept in a simple or a general way, that we want that our optimization for a certain controller design should give you one of the best results. Best means it can vary from problem to problem, that what actually you want to achieve. Okay. In the same way, we have also done some of the research in terms of the microgrid by varying the load at the different instant of the time. And these are our frequency as well as the responses of diesel engine generator. So what we have seen is that, and at the same time, we are also trying to verify these results with the help of OPAL-RT. We have verified these results so that we can do the analysis in real time also, because it's very important, guys, that before developing the prototype, you should do the software analysis. Okay, you can't develop a microgrid by knowing nothing about that, what will be the constraint, will be the capacity of the microgrid, and all those things. And you also want to know that what kind of the favorable conditions should be there. Okay, you can't install the wind turbine without knowing that what will be the minimum cut-in and the cut-out speed. So that is why I have written that standalone microgrids and the multi-microgrids is an important area of research, and a lot of advancement has been done over the last few years. However, it is still need further research and investigation, because this is only the one part. Okay, and there are a number of the aspects where a lot of research is going on in terms of the standalone multi-microgrid, and we also have to see the energy storage devices. We need the energy storage devices with lesser responding time in order to manage the variability of wind and the PV sources. The study should not be limited to the software simulation. Prototype can be developed, and still, as I've discussed with you, that in number of 692, I can say that microgrids are operating in actual working conditions in the US. In our South Africa also, there are more than 25 microgrids available, and they can be further enhanced and improved with the help of the latest AI-based techniques, and they can be verified with the help of OPAL-RT and RDPS simulator. With all this, I conclude, and you are more than welcome to ask any question or doubts if you have.
Thank you, Gulshan sir. I would like to ask the students if they have any query. They are free to ask Dr. Gulshan.
Students, you are more than welcome to ask any question or queries if you have. Good morning, Professor Danish. I can see you now. Good to see you after a long time. I can't hear you. Maybe your mic is muted.
Hello, Dr. Gulshan. How are you?
Hello, sir. How are you? Good to see you after a long time.
Unfortunately, that we could not interact when you were here in India. But I must say, everyone, that Dr. Gulshan is actually a classmate of mine during our MTech program, and we were studying together in our when we were there doing our MTech. So it's great to interact with you again. And
thank you so much. Thank you
very
so much.
unfortunate that we could not host you in the institute when you were in India. And probably next time when you come, we look forward to actually hosting you.
No problem, sir. And thank you so much for providing me an opportunity to share some of the ideas with you. And maybe if your students are interested, they can come and work with us. We have a lot of programs where student can do the internship or something. And we have OPAL-RT, RTPS simulators with us. And yes, we can send them to the power grid also, where they can solve a lot of students are working on the real-time problems of our industry as well as for the power grid. So that is not a problem. And then they can also have diverse learning, and they can learn with the
they must be very it was a very intriguing lecture. So the concepts of microgrid and distributed energy resources, they are really finding applications these days because of the concept of the interconnected grid and the associated frequency fluctuation and all that. I'm quite sure that the interested student will really like to associate it with you. We will provide them with your contact informations whenever they require. And there are a couple of students who are actually doing projects on interconnected system, but they are mainly focusing on the conventional power generation systems, but they are trying to integrate some amount of renewable into that systems, and I'm sure they will. If they face any problem, they will surely interact with you, I'm sure.
No
In
problem.
that case,
Welcome. No problem, sir. No problem. Student, if there is any question or concern, please let me know. Otherwise, I have another meeting with my head of the department at 12:30.
So I think there is no query. I think we can conclude this session. Dr. Shahid. Thank you, Dr. Gulshan. Thank you so much.
Thank you so much. Thank you so much, Dr. Gulshan, for this wonderful lecture.
Okay. Thank you so much, Professor Shahid. And thank you so much for
Thank you.
providing me an opportunity to discuss my ideas with you. Thank you so much, sir.
Okay,
bye.
sir. Thank you.
As the Departmental Research Committee Chair and Faculty Research Committee Representative in the Department of Electrical Power Engineering at Durban University of Technology. He is registered with the Engineering Council of South Africa, the ECSA. He has received a Y-rated research award from NRF South Africa in 2021, and also the Best Researcher Award from the Department of Electrical Power Engineering, Durban University of Technology, South Africa in 2021. He's acting as the academic editor of International Transactions and Electrical Energy System Journal, Hindawi, and also as the academic editor of Journal of Electrical and Computer Engineering, also at Hindawi. He has received research funding from various research agencies. He's published more than 200 research papers in international journals and conferences, and has been continuously engaged in guiding research activities at graduate, postgraduate, and PhD levels. His area of interest includes power system operation and control, renewable power generation, and applications of AI techniques to power systems. We are overjoyed to have you with us, sir. Thank you for taking the time out to be with us today. Thank you.
A very
Thank you so much.
Dr. Sharma, sir. Thank you, sir. Please, sir, start your presentation.
Okay. Thank you so much, Professor Shahid, and thank you so much for such a brief introduction. And I would like to thank Professor Shahid and the head of the department for providing me an opportunity to share my views and some of the research work on microgrid concepts, operation and control strategies. So I will switch off my video camera for as long as our presentation will go, and then I will switch it on again so that we can interact. And if you have any questions, you're more than welcome to stop me, to ask me. So let me start quickly. Okay, so right now I'm on first slide, and today's our topic is microgrid concept and associated control strategy for standalone and multi-microgrids. Okay, and the reason of choosing this concept is, guys, that these days the energy crisis is a major problem all over the world. If you go to the US, if you go to the Europe, and especially in our South Africa also, this energy crisis everywhere. And that is why it has been seen over the last number of the years that the conventional power system is struggling with the major losses in the system. Almost there are 22 to 23% losses in the conventional power system when the power is generated, transmitted, and distributed to the consumer. And these days, especially if I take the example of the South Africa, due to number of the political reason and other technical reason, most of the power plants are old and outdated, and the efficiencies are very, very less. And finally, it results in the load shedding. And you will not believe that these days the conditions are in such a way that the Eskom who generate the power, and they are the completely monopoly of this, I can say the company, that they are totally responsible for generation, transmission, and the distribution. The concept is not same as in case of the India also. And you will not believe that they are not able to manage the generation with the load. And that is why they have come up with the concept of the load shedding. Okay, and you will not believe that they have come up in the number of the stages of the load shedding, that the stage 1, stage 2, stage 3, stage 4 in such a way. For example, stage 1, there will be 2 hours of the load shedding. Stage 2, it will be 4 hours in such a way. Okay, so it has been seen over the last number of years that what will be the possible or the potential solution for, or I can say, to overcome this or these kinds of the load shedding, as well as to meet the energy crisis all over the world. And the concept the name is microgrid. Okay, so I will try my best to keep this presentation as simple as, and if you want to further discuss, then you are more than welcome to discuss with me. Now, what is microgrid? A group of interconnected loads and distributed energy resources within clearly defined electrical boundary that act as single controllable entity with respect to the grid. So, the concept is that in order to overcome the losses of the conventional power system, why not to generate the electrical energy near to the load, near to the consumers? And that is the concept of the microgrid, that we have to develop a certain kind of the sources of electrical energy near to the consumers, where they can consume it straight away, and we can get rid of the transmission and the distribution losses. Because in conventional power system, majority of the losses are in your transmission and the distribution system. And one of the reason is that in microgrid, the power will be generated at a small scale. Okay, and that is why it is very important that we should generate according to the requirement. So that is why before installing or commissioning any microgrid, it is very important that you do the load forecasting or the survey, that what is the actually a load requirement of any society, any complex, any hospital, or maybe any university also, so that once we will be able to know that what will be the load requirement, the base load and the peak load, so that we can generate or we can develop the microgrid in such a way that our microgrid should be capable enough to meet the energy requirement of the customers connected to that microgrid. As I said earlier, that microgrid will not have the same capacity as had conventional power system. If you have seen in a conventional power system, the power is generating at 2000 megawatt, 4000 megawatt in such a way. And those plants are very, very old and the efficiencies are very less. If you look at the conventional power system, maybe the coal power system, the efficiencies are 28%. Some of the regions have the 37% and 38%. But if you go for the microgrid, the efficiencies start from 70, 75%, 80% also. So that is a major role that we want, that we should have a potential solution for the energy crisis, as well as we want to overcome, because these days it's very difficult to manage the generation with the load, because it's a problem during the peak hours that is difficult to manage the generation and the load balance. At the same time, it's very also important that we should cut our transmission and the distribution losses. So the microgrid is the concept that we will generate near to our load center. So first we have to identify that what is the load requirement. That is very important. There are the three different types of the load. When we go for the modeling, one is the residential load, commercial load, and industrial load. And then we have to see that what is the base load and the peak load that will be connected to the microgrid. So you can see that I have written universal local power generation for local load comprises of various small power generating sources. It means that microgrid can have number of sources, means we can have the power that is generated through the wind turbine, Okay, it can be a horizontal axis wind turbine, 3-blade. If you go to the Switzerland or the Europe, you will find that mostly they are generating the energy with the help of the wind turbine. At the same time, you can have the solar PV arrays that can also generate the electrical energy. At the same time, it's very important that we should also have some sort of energy storage devices, because you know that these sources, okay, because we are going to these sources like wind as well as the solar PV arrays, and they are intermittent in the nature. And that is why, guys, it's very important that we should store the energy so that if there is a load requirement more than the generation, then we can use these energy storage devices. At the same time, if the wind energy is not available, at the same time, if the solar radiation is not available, our microgrid should be capable enough to generate the electrical energy and meet the requirement of the consumers as well as the customers connected to the microgrid. I'm going to next slide now. So it is written, it is connected to the both local generating unit and the utility grid, thus preventing power outages. So one of the good concept is that the same microgrid, okay, it can be connected to the grid also. Okay, so the power can flow from the grid to microgrid if the microgrid is not able to generate the sufficient electrical energy. At the same time, if the energy generated is more than the requirement of the customers of microgrid, you can sell this power back to the grid also. Okay, so it's a two-way that the power can flow from microgrid to the utility grid and from utility grid to the microgrid. The size of microgrid may range from housing states to municipal regions. Okay, so as I said, that it depends upon that what is the load requirement, and according to that, from few kilowatts to some megawatt, the microgrids can be designed. Okay, so that is the concept of microgrid. The grouping of interconnected loads and distributed energy resources can operate in island or grid-connected mode if desired, act as a single controllable entity to the grid. So it means that microgrid can operate in two modes. One, it can be connected to the grid, and I will show you in some of the next slide. And in one is island. Island means now the microgrid is totally on its own and can meet the energy requirement of the customers who are connected to the microgrid. Now, components of the microgrid: distributed generation. Distributed means wind power, solar power, okay, or I can say the PV, the power generated from the solar PV arrays, as well as we can have the power generated from the diesel engine generator. Recently, or maybe last number of years, the people use the diesel engine generator as a backup power in the microgrid, because as I told you that these sources are intermittent in nature, and sometimes if the customer need the power, they don't care that how you are generating the power. Okay, so sometimes it's very important that you should have a diesel engine generator as a backup in your microgrid. We are doing a lot of research, and as we have seen that diesel is very, very costly, and we are doing in such a way that we should come up with a biogas or some other kinds of the generator. But recently, the most of the research on the microgrids, there are 692 microgrids available in the US, a lot of microgrids available in the South Africa also, and in Europe also. They all are using the diesel engine generator as a backup power. Okay, then there are the loads. Energy storage system, as I have told you, that energy storage means the batteries, fuel cells, okay, battery energy storage systems, ultra capacitor, superconducting, magnetic energy storage systems. All these kind of the energy storage devices are required so that we should be able to make a self-sustainable, or I can say the sustainable microgrid, in which we should be totally disconnected from the utility grid, and microgrid should be capable enough to meet the energy requirements of the customer. Static disconnect switch, controller's point of common coupling. Static disconnect switch is used so that if there's a requirement that we don't want any kind of the power from the utility grid, then our microgrid can operate on its own. If there's some kind of the faults also, then also you can use this kind of the switch. At the same time, the controller's are very, very important. They play a major role in the microgrid, and we will see some of the next slide that what are the actual requirements of the controllers in the microgrid. Energy storage system, as I have discussed with you, includes the electrochemical batteries, supercapacitor, superconducting energy storage, flywheel. Each kind of the energy storage has some of its advantages and the disadvantage, and it totally depend upon application that what actually is the requirement and where you need these kind of the energy storage systems. Okay, ESS store the energy at the time of surplus and redispatch it when needed. It means that if we have the power or the electrical energy more than the requirement, then this energy can be stored in these energy storage systems. And when there is a defect in the power, these energy storage devices, their times of operation is very, very less. They can fit the power into the system very quickly and can manage the balance between the generation as well as the load of the system. Energy storage systems plays an important role in the microgrid. The sizing of ESS to be considered first when considering ESS in the microgrid. Yeah, it's very important that first you need to know that what will be the total load on the microgrid. After that, you should also know that how much energy will be generated and you can store it, because it is very important that if you are trying to design a self-sustainable microgrid, then it should be on its own. It should not be connected to the grid again and again. And that is why you should have the batteries, or I can say the lithium-ion batteries, ultra capacitors, or other like SMA, superconducting magnetic energy storage, ultra capacitors, or hydrogen electrolyzer. They all, you have to first know that what will be the total capacity and how much energy can be stored. Okay, that's very important. ESS increases the reliability of the power system. The cost of ESS include one-time ESS cost and the annual maintenance cost. So it's very important that your total cost of electrical energy generation will be less than as compared to what you are buying the power from the utility grid, because you need to install the complete setup only at one time, and then it will depend upon the maintenance cost of these devices. This we have already discussed energy storage technologies. Now, ESS in islanded microgrid. Islanded means there are two concepts. Microgrid can be connected to the conventional grid, or it can operate separately, which is known as islanded microgrid. So I have written the sizing of a suitable battery bank in terms of power and energy help in saving the peak demand. Means that if you have a battery bank, then the sufficient energy can be stored in case your wind is not available, solar radiation is not available. In those concepts also, or I can say that in that case also, or in case there is a sudden peak demand, okay, during the peak hours, maybe from 5 to 8 in the evening, okay, or maybe from 9 to 11, then the energy which is already available or stored in these battery bank can be used to maintain the balance in the system. It can store the excess renewable energy. You know very well that we need minimum cut-in and cut-out speed through the horizontal axis wind turbine so that it can generate the electrical energy. Okay, and if there is an excess renewable energy, then at the same time we can store those energies with the help of the energy storage devices, and at the same time when the energy is low, we can use this power to meet the load requirements of our customer. ESS discharges this energy to the power grid. It's generated positive real power, means the power can flow in either way, that you can fit the power into the grid. At the same time, if there's a surplus power, you can store that power also with the help of these energy storage devices. This we have already discussed that in grid connected mode. Now, conventional grid versus microgrid. As I have said in earlier, the efficiency of conventional grids are very low in comparison to the microgrid. Large amount of energy, if you take the example of the thermal power plant, is wasted in the form of heat, okay? But in microgrid, as I said, the microgrid overall structure will vary from few kilowatts to some megawatt, and that is why the losses will be much lesser, and there will be no transmission and distribution system, guys. And that is why the microgrid will have a better efficiency, or I can say the higher efficiency in comparison to your conventional power system. Now, this is a layout of AC microgrid structure where you can see my cursor. These are main grid, point of common coupling, and then there's a transformer here. And then this is a microgrid centralized control station, okay? And here you can see that this is the representation of AC microgrid, and we can have various sources, okay? You can see here we have micro turbine, load, and energy storage devices. At the same time, here we can have a PV and a load. In the same way, here we have fuel cell, flywheel, and then CHP here. Okay, so you can see that, and at the same time, here we have the controllers to operate and regulate micro turbine. For a load also we have the load controller, because these sources may generate AC or the DC power. So at the same time, you need the converter so that it can convert AC into DC, and then DC is back into the AC. In the same way, because this is the AC microgrid, guys, and it's very important that PV is generating the DC power, it need to be converted into the AC. At the same time, if you have the wind turbine is generating the AC, so you don't need to convert that power. So it's very important that your microgrid will have these small sources, and you can see that we have a sources also and the load connected. At the same time, all these information should be sent to the microgrid centralized control station, because we need a control system where our operator will sit and see that what is the actual status of the various sources, what is the load requirement, how to manage the load requirement. That is also a different area of the research that is known as load management. So it's very important that we should have a control station, okay, where there should be the complete information. Maybe you guys know very well, like earlier the people use the supervisor control and the data acquisition system, so that all the information will be sent to the centralized control station, and there should be a team that can operate the complete microgrid. This is also the same representation as I have told you, and here you can see that this is your microgrid centralized control station, okay, that is responsible that whether we need the power from the main grid, or if we want to sell the power from microgrid to the main grid. And that is why you can see that we have here, you can see that we have the switches here, okay, or here you can see that this is the secondary control. This is the secondary control, means that there is a centralized control station. At the same time, this is the secondary control where we have the controllers for each of the sources, whether it is generated the power or it is consuming the power as a load. Okay, so that is also the same concept in a better way. Now, we have seen in last number of the years that you can see two pictures here, that we want that microgrid should be self-sustainable. It means that we don't want that microgrid should buy any power from the grid. Okay, we should feed the power to the grid if there's some kind of the maybe unbalancing, if there's some kind of the load shedding, if there's some kind of the fault in the system, but we don't want that we should buy the power from the grid. So the concept came into the market, that is, why not to connect all the microgrids, okay? And that is a concept of multi-microgrid. You can see in a second picture, which is at the bottom of the slide, that we have microgrid 1, 2, 3, and 4. Okay. If we will connect the 4 different microgrid, means try to understand in such a way that we have 4 complexes, okay, and each complex, and you know very well that their load requirement will be different, okay. Their base and peak load requirement will be different as per the requirement of the customer. That is a group diversity. Okay, so that is why it's very important that we should see that if we can connect the 4 complexes in such a way that if at any point the energy requirement of one microgrid is less than the another microgrid, then the power can be exchanged between the microgrid. And that is the concept of multi-microgrid. And it is also possible that each microgrid cannot have the same structure. Means that if one microgrid is having a wind turbine generator, then second can have a solar PV. Okay. At the same time, we have a diesel engine generator also. At the same time, one of the benefit is that if the microgrids are connected, interconnected, okay, then we can get rid of the diesel engine generator. Okay, and in a worst case, if still the energy requirement is more than the power than the load requirement, then yes, we can open the switch and the power can flow from the grids to microgrid. And then with the help of a control system or with the help of the operator, it can be managed between the different microgrid. So this is the concept of multi-microgrid, where microgrids can be connected and still their efficiency will be much better and they will be self-sustainable. Okay, so that is the concept of multi-microgrid, where number of microgrids can be connected. Okay, so that is one of the things. I'm going to next slide. Now, this is a single line diagram, as we have discussed, that there can be a 3-blade horizontal axis wind turbine. It can be the vertical axis wind turbine also. These days, a lot of research is going on the Darius and the 7S rotor type wind turbines. Okay, so this is the, but still, if you go in the major part of the Europe, then they are using the horizontal 3-axis blade wind turbine. So here you can see that this is a wind turbine generator. We have a solar PV fuel cell. At the same time, there's a diesel engine generator, battery energy storage system, there can be flywheel energy storage system, and then you need controllers. Okay, so in the next slide we will discuss that what is the role of controllers in microgrid. This is the transfer function representation. Okay, and first I will give you the details of. Okay, so microgrid, as we have discussed, that we know the concept of microgrid, as well as we also know the concept of multi-microgrid. But now it's very important that microgrids also need to follow a certain regulation with respect to your frequency, voltage, or power quality. There are the 3 issues that need to be addressed, okay, in order to provide a quality electrical energy to the customers of the microgrid. Okay, 3 issues need to be addressed separately to be very clear, and that is why here I have shown the issue of frequency, because there are number of sources available and wind can change with respect to the time. There may be possibility that enough solar radiation is not available. So in those cases, it's very important, guys, that we should match
Dr. Gulshan,
our generation with.
sorry to interrupt you.
Yeah.
Actually, this meeting will stop in 2-3 minutes. So I think we should stop another meeting. I have already created the link and sent to you.
Okay.
And
okay.
all the students, I request all the students to join by the other link I have sent to you on WhatsApp group. Okay. So I'm starting another meeting.
Okay.
So Gulshan sir, I request you to join in that meeting.
No problem.
Thanks.
No problem. Okay. Thank you.